Come on, recording. You can do it. There we go. Okay, so where was I? False implies false is true. False implies true is true. True implies false is the only case when an implication is false. True implies false, false. So you should get true, true, false, false as your final column for that one. Oh, man. Man. There we go. Now this is 1, 2, 3, 4, 5, 6. Okay, so you'll have on your quiz today, you'll have a one like this, but it's got one extra column, so it's a 7 column instead of a 6 column. I think the other day I said I wasn't going to give you an 8 row. I lied to you. I'm going to give you a 4 column 8 row, so it's an 8 row, and really, no wait, 5 column. But literally the only things you need to fill out are the last 2. Like the 3 are the original setup, and then you just have to really think about the last 2 of them. Yeah. So for this last column, we have the not P row, and we're implying it to the kind of and statement row. Column, geez. So in our first row, we have false implies false. Now remember, whenever you have an implication, if it starts with a false, the implication is true, because remember, it's kind of like a promise. If I say, if it's raining, I will drive you home, but it's not raining, I didn't lie to you whether or not I took you home. So false implies false ends in a true. And then we have a false implying a true, which again, doesn't matter what the implication ends in. If it starts with a false, it's going to be true. I didn't lie to you if I say if it's going to rain, I'll take you home, and I still drove you home even if it's not raining. So false implies true gave us the true there. And then for these last two are essentially the same thing because it's both true implies false. So for the true implies false, that's the only case where the implication is false. That's me telling you, if it's raining, I'm going to drive you home. But then it rained and I didn't drive you home and I'm a liar. So the only time that our implication is ever going to be true is if the hypothesis, the first kind of statement, is true and the conclusion, excuse me, the second statement is false. So it doesn't matter what those statements are. It doesn't matter how complicated these things are that we're looking at in the implication. The only way that's going to happen is if it's true implies false. No problem. That's the one thing you got to keep track of. And then P's and Q's look very similar, so it's just, well. We do have a quiz today. It's going to be towards the end of class. If you can do this warm-up, you should be perfectly fine on the quiz. That's kind of how I do it. I do the warm-up based off of what you would need to know on the quiz. So having said that, if any of you feel iffy about any of this, ask me questions now before we start our notes so that you can do well. So again, what was I saying? I lied to you the other day. I said I wasn't going to give you an 8 row, and I lied. But it's an 8 row, but a very small one, column-wise. So it'll be something similar to this. There's not a ton of things you need to look at. This one is actually going to be slightly larger than the one on your quiz. But we have P, Q, and R, so we have 3 variables, so that's why we need our 8 rows. True, 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 true. Oh, I need to really scroll down, sorry. Was trying to keep that other one in there. True, true, false, false. True, true, false, false. And then alternate. So the one on your quiz, you'll essentially just have 2 empty columns that you need to fill out, so it's really not that long. I know it's got 8 rows, but it's not that big of a truth table compared to a 4-row, 7 column. So here in this one, we need 3 things though, because we have a not P, the or statement, and then the implication. So this one is slightly larger than the one you'll see on your quiz. So not P, just negate everything you see in the P column. So it'll be false, 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 false. True, 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 true. Q or R, one of them has to be true or both. So we would have true. So let me just, that's a really terrible highlighting job actually, but anyway. So true, true gives us true, true, false, true, false, true, true, false, false. We come to our first one where both of them are false, so that's going to be a false. True, true gives us true, true, false, true, false, true, true, and another false, false, gives us our only other false. And then our implication, we're taking not P and we're implying it. So remember, the order matters with implication, so be careful. Sometimes you're almost viewing it backwards, but in this case we're kind of going forward, so that's nice. So false implies true would be true, false implies true, true, false implies true, true, false implies false, true. So anything that's false implying something else is true. And then we got our trues, so we have 3 sets of true implies true. So true implies true is true. But then this last one is finally a true implies false, which gives us a false. So that was so close to being a tautology, but that last one messed it up. Questions, concerns on that one or the last one by any means? Any on the truth tables before I go over to the other thing? Okay. Hold on like 5 more seconds. All right. So these ones over here, this is where we're justifying with either an equivalence or inference rule. And remember, you'll have them. I mean, you can have them on a different screen or something like that, but I've also put like a question, quote unquote question, in the quiz that has the rules listed. So you won't need to worry about that. And actually, I haven't actually finished it yet. 1 second. Blank. And there we go. Okay. So for this first one, Mary is a dancer and a runner, therefore Mary is a, yep. And actually, that actually is nice because I need to check something real quick. So I will check that as, let me look at that real quick. Oh no, that's gross. Ugh. That's unfortunate. All right.
Professor,
Anyway.
can I ask you a question real quick?
Yeah.
Can you explain why the last column, the last one, is false?
This one down here?
Yes, ma'am.
So we have a true statement implying a false statement. And that's the only case when an implication is true. If you think about like an implication as a promise, like if it is raining, this is my favorite example, I keep using it. I will drive you home. If the first part is true, if it's raining, so the first piece is true, but the second half is false. If it's raining, but sorry, gosh, I can't talk. If it's raining, but I don't drive you home, then I'm a liar. So since I promised you that if it was raining, I would drive you home, and that it is raining, but I don't drive you home, then that statement that I told you was false. It was a lie. So that's kind of the reason why that's the only one that turns out to be false when the hypothesis is true, but I lied and didn't go through with my promise.
Thank you.
That's why that ends up being false. Alrighty. So we got this one. Mary's a dancer and a runner, therefore Mary is a dancer. So first thing I like to do with these is I like to write it in terms of symbols because I like to look at them better than the words. So essentially Mary is a dancer, let's just name that D, and she's a runner. And remember the word therefore or something like in other words or in conclusion, anything like that is going to tell you to kind of like split it up. So we have Mary is a dancer and a runner, and Mary is a dancer. So we're essentially trying to say, how do I get from this to this using one of our rules? And I should have put the rules on this page, but I don't have them up. Our simplification rule was if we had a P or a Q, that could then go to just P, which is essentially exactly what's happening here. So this would be by simplification. Simplification. I can't speak. One other thing I want to say about this specific question is another way I could phrase this type of question is I could just tell you the Mary is a dancer. and Mary is a runner. And then nudge, nudge, wink, wink. I could ask you, what can I conclude? Whoa. Conclude. That also CL looks like a D. By simplification. And then you would have to tell me the answer was Mary as a dancer. So I can also kind of ask you to use the rule to tell me the resulting statement as well. So there's like two different types of ways I could phrase this question. If we look at our next one, let me try to move this one down a little bit first. Hold on. Get down there. All right. So we have Joe is a banker. So I'm going to name that B. And then we're starting a completely different sentence. So we're on a different statement. If Joe is a banker, then he owns a house. Maybe I'll name that H. And then we've got our word therefore to tell us that we're going to the conclusion after that. Joe owns a house. So I have to look for a rule that has an implication and a second piece, and it goes to just the essentially conclusion of the implication. So remember, the ones that deal with implications, you're down to three things: implication or a modus. But the only ones that deal with two separate things are the modus ones. So we're essentially between modus ponens and modus tollens. The only one that doesn't deal with negations, because we don't have any negations here, is modus ponens. So this would be modus ponens. Sorry, question. So we will need to write the variables along with the rule, or just write the rule. Okay, so for the answer, you would just need the rule. When I'm doing these, I just like to write the symbols down because it makes it easier for me to see what rule it is. But you don't have to include essentially just what I've boxed is what you would need to put in on the quiz for the answer. You would just need to write simplification and modus ponens. You wouldn't need to show the doodads. So that would be modus ponens, because we have the hypothesis of the implication by itself, and then we have the implication and it's resulting in the conclusion. So that gives us modus ponens. Questions on why that's modus ponens before I do this last one? All right, so then we have, if Ida is cold, then she will grab a blanket. I'm just choosing random letters that I like out of the sentence. In other words, so again, we're starting another sentence, but we also kind of have this phrasing that's telling us that it's a new result. So we want to see what gives us that. In other words, Ida is not cold, or she will grab a blanket. So essentially we're starting with an implication and we're going to a not hypothesis or conclusion, if you will. So we look at our rules. The only three that deals with implication are the implication and the moduses, but the moduses need an extra thing, so it's probably implication. Let's triple check. So our implication rule tells us if we have P implies Q, that we can go both directions and get not P or Q, which is exactly the format we have here, just with different letters. So in this case, we could technically also go the other direction, but the point of the question was really just looking at the one direction. That arrow looks really dumb. So this would be, what did I just say? Implication. And again, I could phrase this in a different way. I could just give you, if Ida is cold, then she will grab a blanket. What can you conclude by implication? And you would need to tell me Ida is not cold or she will grab a blanket. So there's kind of that other form of this type of question as well. Questions, concerns on any of that, any of the warm up in general? We zoom out a zoom. It's not zooming. There we go. Try to get it all in there a little bit. Where did the in other words come into play? So notice that I've highlighted something in all three of the examples. The first two were therefore, and the last one was in other words. It's not quite starting a new sequence per se. It's telling you where, I want to be careful with the word. What word do I want to use? It's essentially telling you where the, and I didn't draw one in the first one. Let me draw one in there real quick. It's essentially telling you where kind of this double arrow is going. It's essentially telling you where you stop what you know and you start what, nope, I don't like how I phrased that. It's essentially separating the things you're starting with and the things you're ending with. So therefore, in other words, in conclusion, anything that sounds somewhat similar to that kind of phrasing is going to tell you this is when we've stopped giving you the things you start with, and now we're giving you the thing that you are ending with, and that's kind of where you need to find the connection. Did that make any sense? My phrasing on that was all over the God's creation. I don't know if that made any sense. Okay. Do we need to memorize the rules? No. I think I said this last time, but just a reminder, I suggest trying to be pretty familiar with a couple of them. So the ones that you're going to be using like a ton that you would probably want to be pretty comfortable with are implication, De Morgan's, double negation. That one's kind of simple. I should avoid the word simple. Honestly, those three, I would try to commit to memory. You don't have to, but I would suggest it because they're used so often. So if you can save the small amount of time by not having to look over at it and use it too much, excuse me, it can be super helpful in saving you a little bit of time. But you don't have to memorize anything, any of these, I should say. All of these rules will be given to you on any assessment that you need them for. But those three are real hefty ones. Well, hefty in that they get used a ton. All right. Any more questions about the warm-up before we move on to notes? Going once, going twice. I'm gonna head over there. Boink. So we are on part 2 of section 1.2. No, that's gonna take too much time. I don't have time to do that. So if you want the rules, you might want to try to grab them on a different screen, or, you know, smush the windows together with somewhere that you have it, or if you have it on paper in front of you, because I should have put them off to the side, but I forgot. So anyway, part 2, section 1.2. So essentially the other day we learned all of the rules and now we're going to actually use them. Well, we use them a little bit, but we're going to use them in kind of their more useful way. So definition, a proof is a sequence of equivalences and implications to justify an assertion of the form something implies something else. I don't want you to get it bogged down and say it's just one thing implying one thing. Those A and that C can be absolutely as long of a statement as it needs to be. So that's just saying something implies something else. And remember that this double arrow is implying that it would be a tautology. So we're essentially trying to take something and use a bunch of things that are true to prove that it truthfully goes to the other statement. So we're going to start by completing a proof table. We are going to do some proofs completely from scratch in a second, but first we're going to start with something that looks like this. Now, a lot of your homework, yeah, no, I think there's only one like this on the homework. That's actually in this setup. Anyway, especially in terms of assessments. So if you have a quiz on this, maybe next week, and especially on the first test, all of the proof ones will be given in a similar fashion to this, where I won't ask you to do one from scratch. So on an assessment, I won't ask you to do one from scratch. You do have a couple on your homework from scratch, which is just good practice. But all of the ones on that you're going to actually be tested on will be something like this, where you just have to kind of fill in the holes. Anyway, suggestions. I'm going to write this off to the side real quick. My biggest suggestion I can give you, because this can be kind of complicated, is look for what's different. Different. between the lines. And then look for, look for what rule deals with those changes. Because again, the rules that were given, it doesn't have to be exactly in that format. It doesn't have to look exactly like P implies Q. It could be a P or Q implies R or something like that. So I find that a lot of people get bogged down in trying to match the notation too much. We're trying to kind of match patterns here. So if we're looking at this one, now essentially proofs always start with things that were given. So in this case, this is the only thing that you would be starting with if you were doing this from scratch, and everything else would have to be filled in. Well, you would know what you would trying to go for. So essentially, if you're doing something from scratch, you're given essentially the first step and the last step, and you need to find all the things in the middle. So we have this thing that's given. So let's look at, line 1 to line 2 and see if we can spot some differences. So I noticed that the implication symbol becomes an or, and we have an extra not. We pick up a not. So those are the two things that I see that are different. Essentially everything else is the same. Not P and Q stays the same, that R stays the same. So those are really the only two differences. So then what you would do is you would pop over to your list of rules, which I really wish I had here, but I forgot to put it out. And you want to look for something that deals with an implies going to an or. So that's the main thing I would focus on, is the implies to the or. Keep the not in the back of your brain for a second, but focus on the fact that that implies symbol is becoming an or. And so if we look through our rules, again, the only three that deal with implies are the modus and the implication. But the only one that deals with an implies and an or is implication. And notice that in implication, so our implication rule, so I'll kind of quickly write it off to the side to remind us of what's going on here. It changes the implied to an or, and it does pick up an extra not in the front. So let's triple check that that's the correct pattern. So essentially we start with something, that thing stays the same but picks up an extra not. So the P becomes not P. So our not P and Q has to become not P and Q, which it does. And then the back piece should stay completely the same, which it does. So that does follow exactly the correct pattern for implication. So we're going to say implication. And then you always list the step that it came from. Now, most of the time you're just going to be using the step directly above it, but in some things we'll see in a second, sometimes you use ones that are, sometimes you have more than one given, so things start to get a little more all over the place. But essentially, to get from line 1 to line 2, we use implication on line 1. So we're going to write a little 1 over there. Sometimes, and I think on your homework, this is written, this is considered what's called a step, I think it's called a step in your homework. But anyway, you'll have a thing on your homework where it has a drop-down box for the rule and then a kind of blank space to the right of that. And that's just wanting the number of the line that the rule was used on. But usually I'll just write them as one whole thing. Okay, as always, stop me if you need to. This is a tricky thing. It takes a lot of practice. So this is feeling difficult. It's because it is. And it takes a lot of practice. Sorry, I changed colors and I want to just keep everything together. If it seems complicated, it is. What's up?
Which guided notes are you using right now?
This is the 1.2 part 2. Is that not what those look like?
Found it. Okay, thanks.
Okay, cool. Yeah, 1.2 part 2. All right, so then we're looking at line 2 to line 3. So what's some differences here? Well, the or R in the back stayed the same, so that's not different at all. This symbol in the middle changed, so the or became an and. And essentially that negation, I'm going to say came inside. Essentially came inside those parentheses. So those are really the only two differences, is that the negation kind of came inside and went to both of those things, and the and became an or, but then everything else stayed the same. So we look over at our list of rules, and we look for something that deals with an and becoming an or and a negation being moved. And if we look throughout our things, the only thing that deal with negations, the only rules that have negation in them, is Modus-Tollens, double negation, and De Morgan's law. This one looks way more complicated than double negation because we have an and that becomes an r, and double negation doesn't do anything like that. Modus-Tollens doesn't have any and and ors, so that ain't it. So it must be De Morgan's, or at least that's going to be the most likely, and we need to triple check that it does follow the correct process. So for De Morgan's, what De Morgan's tells us is essentially that negation comes inside and it goes to both of the pieces, which it does. The not p becomes not, and the q becomes not q, and the sign in the middle flips. So that does follow the correct rule, the correct pattern for that rule. So this is going to be De Morgan's. Technically De Morgan's law, but I usually just shorten it to De Morgan's. So De Morgan's on line 2 is what gets us line 3. And then from line 3 to line 4, what's the differences? Well, the only difference that actually happens is that we have this not that kind of quote unquote disappears. So we have the not goes away. I'll put in parentheses, not parentheses, quotes. And I'll spell away correctly. So the only thing that happens between those two lines is that not goes away. If we look over at our rules, what's the only thing that deals with negations and quote unquote making them go away? The only one that has 2 negations is the double negation. And since that's the only one that only deals with negation and nothing else, that's going to be our right rule. So this is going to be double negation on line 3. And remember, the equivalence rules go both directions. So the inference rules only go one way, kind of, note that the arrows in that table only go in one direction, where the equivalence goes in both directions. So it doesn't matter that we were starting with not P and became P. Like it's still double negation. We can go both directions there. Questions so far? Okay. Okay. For our next line, what's the difference? Well, we have P and, sorry, that's an or, P or not Q or R with some parentheses in certain spots. And we still have a P, we still have a not Q, we still have an R, and the ors are still ors. So really the only thing that changes is that these parentheses shift. And that is the only difference I'm seeing there. It's the only difference that is there between those two, is that the parentheses just shift to the other pieces. So if we go over to our rules and we look for something that only deals with shifting parentheses and nothing else changes. So the only rules that really have parentheses at all to look at are De Morgan's, associativity, and distributivity. De Morgan's ain't it because we're not dealing with negations and none of the signs are changing. Distributive property, we would need one of each. We would need an and an or, and we don't have that. So it looks like associativity is the only one, which is the only one, that deals with moving just the parentheses. So to go from 4 to 5, that must have been associativity on line 4. Again, I do want to clarify, when I'm going to this rule table and I'm saying a bunch of rules and then narrowing it down, because I've been doing this so long, I can usually just pick out what it is right away. So if you can pick out what it is right away without having to consider all the rest of them, that's perfectly fine. I'm just trying to give a bit more of a thought process kind of deal. Like look for the things that deal with the changes and then find the one that actually is the correct pattern. So then from 5 to 6, what's our differences here? So our P becomes not P, so we pick up a not. Our or becomes an implication symbol. But then the back stays the same, so the back didn't get touched at all. So the only thing we're looking at is we're looking at for an or became and implies, and we have a new not, if you will. So we go over to our rules. So the only one that deals with implication and an or, I hate having to say and without meaning the logical connective. But the only one that deals with not negation, implication and ors is the implication rule. And so the implication rule tells us that if we're going from the, now this one, I want to be kind of, so here's our, whoops. Here's our implication rule. Now here we're starting with essentially the left side. That's the right side. We're starting with the right side of this rule. So notice that the rule technically has a not originally. But remember, don't get bogged down in the exact notation. You're looking for a pattern. So if we go backwards, essentially we start with a not, but then we lose it. So it's essentially negating the first piece. Whether it goes to a positive or negative depends on what you start with. So since we're starting with a quote unquote positive P, if you will, and we end with a negated P, that does still follow the correct pattern. And the Q doesn't change at all, so the back piece shouldn't change, which it didn't. So this one would be implication from line 5. Are there questions on any of that? Please do not hesitate to ask questions if some of that doesn't make any sense. Also, again, it does take practice. So if you like kind of followed and you're just feeling kind of iffy on it, hopefully the extra practice will help. But if there's something that you're like, what the heck just happened? Let me know. Hold on like 5 seconds before we do the next one. But please don't hesitate to ask questions. I always get a little freaked out when I think there should be questions and then there aren't any. All right, it's 12:20. Where is the simplification? It wasn't used in this one. We don't have to use them all. So that one just never got used. Haha. Simplification. I think that's what you meant. Simplification. I can't spell. So if you meant where's the simplification rule, it just wasn't used in this case. You don't have to use all of them. We didn't use distributive, we didn't use commutativity, we didn't use double negation or addition or modus or conjunction.
What I meant was to say that you used simplification as one of the things for the answer on the quiz, on the pre-quiz, but I don't find simplification as a rule.
Oh, it should be in the inference. Let me do this real quick. Oh, why don't I just stop being stupid and just do this way? So this is how this is the quiz, don't look at it. But this is the question that'll show you the rules. So it's actually from the inference one. So a lot of the ones that we just used came from the equivalence. So remember there are 2 tables and they're like on completely separate pages. But the simplification one is right here. We start with a P and Q and just go to P. So this will be on your quiz. So you have all of them together in one spot. But go back here. And just to make sure I'm not crazy, because sometimes I am crazy. No. Wait, yeah, that was equivalent. Yeah, there it is. Okay, cool. I do redo these notes, so I wanted to be careful. I was like, I'm pretty glad I didn't delete it in the table somehow when I redid those notes. Okay. So, 12:20. I think we have time to do one more. These take a lot of time to do. So this one's from scratch though. Use a proof sequence to prove that P or Q connected with a not P will give us Q. So essentially, this is what we're given, and this is what we want. So that double arrow thing is always a big thing for these. It's separating givens versus wants. So we're going to set up a table. So statements, and then we're going to have reasons. So when doing something from scratch, the first thing you do is you always put your givens down. So we have P or Q as one given, and since it's on a separate line, it's a separate given. Not P is also a given. And so eventually what we want to work down to, I don't know what number it's going to end, well, I do, but eventually we want to somehow find Q. That's kind of, and we need to fill out how to get there. But let me erase it because I don't know how long it's going to take me to get there. So there's a couple ways to do these from scratch. The one thing you can do is you can look at your givens and just try to look at some rules and figure out what you can start doing. One thing I like to do, and I find works better for me personally, is to almost work backwards. So what I like to do is I like to come off to the side and, well, let me do this. Let me write a little bit of suggestions over here. So my suggestion for ones from scratch is to essentially think about what could give the result. There's an L in there. Result, keeping in mind the givens, I'll say. Now you want to be careful there because sometimes you don't want to focus on the givens too much because you want to focus on some things that you could possibly get from the givens. So if I were to do that here, essentially I want to note that I have P, I have Q. I know they're connected with an OR, but I want to just kind of go very general. I have a not P, and I'm thinking to myself, what could give Q? Now, again, this is where you got to not get bogged down in notation and look at patterns, okay? So I'm going to go over to my rules and I'm going to look at what things could possibly result in just Q, okay? Now, I'm going to go a bit above and beyond, so I'm going to just start listing a bunch of them. So some of them that look like they could give us a single thing as a result. That's the other thing to look for. It doesn't necessarily have to be Q in the rule. What gives us a single thing as a result? Well, if I have, you know, a Q or really anything, but I'm going to put a P there. You know what? No, let me put a question mark because that could be anything. I could get Q from simplification. I don't really have that, but it could give it to me. The only other rules that give us a single thing as a result are the modices. Also, modices are going to be your best friends every once in a while. I know we didn't use them in the last one, but especially when you're given more than one given. So since we have two givens, you're probably going to need a modis. So let's look at both of the modices. So let me look at modis ponens first. And again, this is where you can't get bogged down in the actual notation of those necessarily. So if I want modis ponens to give me a Q, well, that's nice because it's actually how modis ponens is set up. So modis ponens to give me a Q would need this. Now, technically, that could be anything. So it could be R, but here we're just given P's and Q's, so I guess technically I could just put a P there. If you want to put question marks on things that you don't. So there are things that you need, like the Q would need to be a Q, but the other thing wouldn't matter. And then if I look at modus tollens, this one I need to be a bit careful on. So notice that modus tollens gives me a not P in the statement of the rule. So if I want to force it to give me a Q, what I would need is I would need an implication, and notice that the Q in the result must have come from the hypothesis because it's P gives us a not P. So we must have a not Q here. Okay, patterns. And then here we would need this to go to a P and a not P. Or the nots could be backwards. It could be not Q implies not P and then just a regular P. So there's also a couple different situations you could have there. So you could also say something like or not Q implies not P and have a regular old P, and that would still get us Q by modus tollens. So you really want to, again, focus on patterns of the rules as opposed to the actual letters. Now, what the heck was all that hoopla about? So let me change that question mark up there to a P. I forgot that we didn't have R's in this situation. What I now have is a bunch of hoopla that I don't have, but I could potentially work up to. So notice that I have an or, and all of these rules that help give me something that I want either have an and or an implies. So I'm already off to a iffy start. But we have a rule that changes an or into an implies. So that's making these two look rather nice because I can get an implies out of that and. Sorry, it's an or out of that or. I can get an implies out of that or. Does that make sense? So let me think about this a little bit. This is not the official answer, so maybe keep this off to the side somewhere else. But if I were to use implication on this, I would get not P implies Q. None of that is what I need. If it could just become P implies Q, I'd be good to go. But that's not what I have. One moment. Aha. There was another thing that I needed to write down and I forgot. Okay, I can save it. So from implication, we could get not P implies Q. I do notice that I do already have a not P. Notice modus ponens, I need the same thing in the front. So essentially modus tollens is weird because things have to change, like the conclusion has to be negated. But with modus ponens, you just need the hypothesis of the implication. So actually, if we change that to an implies, we're already set up good to go. We have the not P implies Q. We have not P. We could use modus ponens. Does that make sense? These are really hard to explain because it just takes so much time to get used to it. Now, so what that tells me is if I just use an well, I need to be careful. If I can use an implication on that first statement, I can build myself up to modus ponens. Now, proofs, the one thing about proofs is you need to be very specific and very tedious. Technically, I don't want to go, I can't, nope, we can. Well, I want to do a step just in case so that you can see it. Technically, you could jump straight to an implication rule. But something I want to show you just in case because it does come up sometimes is sometimes they take an extra step to be super duper tedious. And they would make that not P or Q first. Because they would essentially, what they're trying to do is that in the normal implication rule, there's a not involved that just disappears. So they would want a not involved to be able to use it. Again, most of the time you can just jump straight to it anyway because we just recognize that going from P to not P is negating it. But because sometimes you can see that extra step, I'm going to do it. Hopefully that's not confusing. It probably is. But that would be using double negation on line 1. And then once they have that not set up in the way they want to, they would then use the implication rule. I don't know who I mean by they, but so implication on line 3, essentially this negation, the first negation would essentially go away. Whoops, I didn't mean to do it like that. Would go away, so we would end up with not P implies Q. Again, technically you could jump from here to here, and I would be okay with that. Some people would say you'd need to take the extra jump. And again, so now I have the setup for modus ponens because I have something implies Q and I have that hypothesis as well. So I have not P implies Q, but I have not P. So I can end this proof by using modus ponens to get Q. So it would be modus ponens, yep. Now technically we use 2 lines for this, so you just list both of them. I like to list them in order, but if you wrote 4, 2, that would be right as well. But essentially we use modus ponens on line 2 and line 4. We have to have them both. And then we're done. There's another way you could have done this proof. If you did something else, you could use modus tollens instead. I might do that at the beginning of class next week. Maybe not. But just know that there are sometimes multiple ways to solve a proof. So again, in this case, I could have done some completely different steps and then actually set up modus tollens instead of modus ponens. Go ahead.
Professor Aaron, I have a question.
Yeah.
Is there a portion of the textbook that can go over this, like, break it down? Because I'm having a little bit of a hard time understanding some of this. And I was just wondering if there was like another part that you could use to reinforce, going over this.
So there's not a lot, to be honest, in your actual book. Proof sequences do start on page 20. But I do think they go essentially through the same proofs I'm going through. Did they use the same thing I did? They did. Haha. What I'll do is I'll go back and I'll try to. I made an extra video last semester, with some extra examples. I'll go back and see if that's not too personalized to that class, and I can add that in. In terms of your book, it's not going to go into a lot more detail than I'm trying to go into. You could read it over. Maybe they explain it in a slightly different way than I do. But there's only 2 or 3 examples in there. But I'll try to add in some, find some supplemental materials to add into Blackboard. It's a little hard with this class because if you were to search this stuff in Google, there's a ton. Not a ton, but there's a lot more equivalence and inference rules that we actually don't cover that usually sneak their way into those. So I'll try to find some supplemental materials. I'll look back into that video that I posted last semester and see if I can post that over too. Yeah, because yes, it's not easy to get your head around at first. I totally get that. Yeah.
Okay, thank you. I appreciate it.
And we are going to go over, we're out of time today. We got to take our quiz. Yeah, it's a lot and we have to move pretty fast. So it's like, here's this really complicated thing. All right, moving on. We do have 2 more to go over. Brain next week. And again, to hopefully make yourself feel a little better, the ones that you will have to do for assessments will be fill in the blank-ish. It won't be as from scratch. The scratch is great practice, and it's good to try to make sure you can get up to that level, but I won't be testing you on from scratch proofs. I will be testing you on fill in the blank-ish type things. But we will continue this conversation on Tuesday. Later in the semester, we will. Oh, right. No, I will never. Well, so there's different proofs later that I will ask you to do from scratch, but they're completely separate. These types of proofs with these equivalence and inference rules, I will never ask you to do from scratch on an assessment. There are 2 that sneak into your homework. But yes, if you want to start the quiz, if you want to stop listening to me babbling, if you have more questions about this, you can ask. But if you want to take the quiz, it's up on Blackboard in the assignments tab. If you would like to do the quiz on paper and email it to me, if that is more comfortable for you, you may do so. That's what I actually looked at earlier and realized it looks really gross. The first two are truth tables, and Blackboard lays it out not as nice as I thought. But try your best. So there's all the little blanks. So there's a time limit set for 20 minutes. It's not going to like stop you after 20 minutes or anything. You shouldn't take more than 20 minutes. So if it's taking you more than 20 minutes, you should take that as a sign that you should study that material more. But it's just there so that I have an idea about how long you take. It kind of gives me an idea of how many people went over that expected 20 minutes or not. So I'm going to stop talking now.
Aaron?
Yeah.
Do I have to take this quiz right now, or can I just do it a little bit later?
Is there a reason you can't take it right now?
I'm at work.
Ah.
I can take it now. It's fine. I just was wondering if I could just, when I got off work, take it then. I can do it now. That's not a problem. I was just wondering.
So we can set it up that you can take it later, but
I'll do this one now, but I'll maybe talk to you, just email or something, and maybe we'll talk about that later.
Sounds great.
Thank you.